everybody, this is Master Mister from the channel Info Dinto, and today I'm going to be discussing about something that has completely revolutionized physics. That is the Standard Model of Particle Physics. Now, Standard Model of Particle Physics created a completely new branch of physics, which was quantum physics, and also gave us a few answers to the questions that we were wondering about our own existence. So now, previously it was thought that the atom is the smallest indivisible particle, but it was not, obviously, because it was found by three smaller particles, which were the electron, the proton, and the neutron. And in this scenario, there are two electrons, there are two protons, and two neutrons. So it is an helium atom. Now let's talk about these three elements. So here we have the proton, here we have the neutron, and here we have the electron. After some research, we were not able to give an answer to a few of the chemical reactions or radioactive decays with only three particles, and then we concluded by saying that although the electron is a fundamental particle, the neutron and proton are not, but instead they are formed from smaller particles named quarks. I'll be discussing what are they exactly. Now let's first take the case of the proton. The proton is formed by two smaller particles known as, first, what you can see here is the down quark and two up quarks. So one down quark and two up quark. Two up quarks and one down quark. But now when we take the example of the neutron, which instead of having two up quarks has two down quarks and one up quark. So now you can see here. So here you can see this is the neutron, and here are the two down quarks, and here is one up quark. Now let's discuss, without talking more about the atom, let's just jump into the main topic of today. So that is the Standard Model of Particle Physics, in which I'll be explaining each and every element, each and every elementary particle with their associated Lego bricks. So hope you enjoy it. So here, as you can see, is our first elementary particle, the electron, having a charge of -1. Now as you can see here, here is the particle that we have associated with it. And also let's now talk about the two quarks that we were talking about previously, and those obviously are the down quark and the up quark. So let's write it down here. So here is the down quark, which has a charge of -1/3, whereas the up quark has a charge of +2/3. Now here we can, as you can see, here is the first generation, the second generation, and the third generation. I'm just naming them so that it's more clear. Later, we also found a particle that closely associated the electron, but instead had a neutral charge, which we later called upon a neutrino. So we call it an electron neutrino. Now let's talk about the second generation. The second generation of the particles was actually a very interesting discovery. Why, you might ask, is because we got to know that there are only not these four particles but some more, and this is like the matter particle column, and here is the fourth particle column, as you can see. So then afterwards we divided the matter particle into two groups, so the quarks and leptons. So there are total 6 of them, and I'll be discussing about them. So like the up quark, we have found out another particle which also was like the up quark with similar charge, but it was slightly heavier. So here we have the charm quark, which also had a charge of +2/3. Now we also found a quark that whose properties were very strange, and thus we called it the strange quark, and it also closely resembled the down quark with a charge of -1/3. Now both of these were similar, but just why were they not found many of the times is because that they were very active, and thus they decayed very quickly. Now we also found another particle which resembled the electron by its charge being -1, but it was heavier. This particle was called the muon. Similarly, we also found a muon neutrino with similar properties, like the charge was there was no charge, and we called it the muon neutrino. For the third generation, it was quite similar, and it shared characteristics with the second generation about being very hyperactive. So here we have the top quark, which also had a charge of +2/3, and here we have it, top quark. The next particle was the down quark, it's the bottom quark. Sorry, it's the bottom quark. So here's the bottom quark, and it also had a charge of +2/3. Now we also found a particle that resembles the electron series, also having a charge of -1, but its mass, oh my god, its mass was as heavy as a normal nuclei. So you can imagine how heavy is this particle. Similarly, we found a tau neutrino to it, which also was neutral. So this is about matter, but things simply just don't exist. They even do something, and to do something they need interaction, and this interaction as we know it is carried out by forces. So there are four basic fundamental types of forces that we have discovered till now. Those are the electrostatic force, the weak interaction force, the strong interaction force, and the gravitational force. And also we found out that each of the thing had a particle resembling it. First, let's talk about the electrostatic force, which was carried out by photons. Now photons are very commonly known, and also the fact many times we perceive that photons are just the carrier of light, but that's not all, because photons, as you probably you might have not known, actually are the carriers of the electrostatic force. They decide the like what type of charge, either negative or positive, that the particular particle would have. So these were photons. Now the photons were basically massless because they did not contain any mass, because they were just a force, and they were constantly transferred by these all particles itself towards each other to create some type of reaction. Similarly, I also discussed about the strong interaction force. So the particles for example, a protons, I discussed two up quarks and a down quark. So they all are together. They are just not simply kept together, but instead they are kept together by particles which are known as the gluons. So these particles are the carriers of the strong interaction force. So strong interaction force. And these were known as gluons. Also, I talked about the weak interaction force. So what is this? Scientists found out that the particle simply two positively charged protons with a charge of +1 could not just simply stay together. But how are they still staying? Then we found out about the weak interaction force, which was carried out by two particles, the Z boson and the W boson. So we have the weak interaction force, which was carried out by the Z and the W boson respectively. They both together contributed. And finally, this whole model united the three of the, we were able to explain these three forces along with this. The fourth force was gravity, which was till now thought that there was a field named Higgs field, which gave mass to particles floating through it. And the Higgs boson, because the particles are discovered by things known as particle colliders. Now, currently the Large Hadron Collider is the most popular one. It's located in Geneva, Switzerland. They found out that a particle existed, but they were not able to confirm whether it was the Higgs boson. So if it was the Higgs boson, then we are sure that the Higgs field exists, meaning that this particular particle is one of the characteristics of the field that gives mass to every particle. Then why does it give mass to these three particles, which are the carriers of energy? Well, it's practically because they are just parts of interaction. They don't need mass. So that is what we can give an explanation, which is which is not so satisfactory. I'll be explaining what there was new theory derived. So here it's for the gravitational force to be precise. So I've just written gravity in short, and here we have the Higgs boson. So there you have it. This is the standard model of particle physics. But why are these all things for? Because I just don't talk about the facts. I also talk about something more, so that people feel more interested. You all must have heard somewhere about dark matter and dark energy, and probably might have been confused. What is this? What dark matter and dark energy and something like that? Well, I'm here to explain you what exactly is dark matter and dark energy. Well, our universe is I'll be talking about it in video, but just in short, I'll be just clarifying it. So, dark matter and dark energy occupy most of the space, but which are not visible by our naked eye and do not react to light as we expect it to. So it's probably hidden, but we can see its effects for sure. So what were my ideas were that all of these particles are there. So probably there might be a particle of dark matter and also dark energy. Now wait, I'll just write it here. So here we have dark energy. Probably a few strange particles, like some particles might have interacted with each other in certain circumstances and might have created these particles, which we call today dark matter and dark energy. So that is my explanation.